Howdy, PreCal. It is Miss Kosh, and today we are going to start conic sections, and we begin with circles. So an introduction or a nice reminder is how to complete the square. So we can complete the square when our leading coefficient is 1 or when it's not 1, and I want to do both of those sort of quickly. We've done this already this year, but let's hit it again. So I'm going to say x squared. I'm going to keep my x terms and add a box on one side and then move anything else to the other side. But if I add a box to one side, I have to add a box to the other side. And now I'm going to come down and say, okay, x plus half of 8 is 4. 4 squared is what goes in my box. It goes in my box here. And this would be equal to negative 15 plus 16 is equal to 1. It said to solve it, so now I do the cheer, square root, plus minus. And I get x plus 4 is equal to plus or minus the square root of 1. Hopefully you realize the square root of 1 is 1. And so then I have an x plus 4 equals positive 1, and an x plus 4 equals negative 1. And so then I subtract 4, x equals negative 3, subtract 4, x equals negative 5. That's a 5, pretend. Okay, this one gets a little bit more interesting because there's a 3. Now what I would do is I would factor out that 3 from my two terms with an x, and I'm going to put a box here. I'm going to move the other number over, so I have to subtract it over. And now notice I'm not just adding a box, I'm adding 3 times the box. So if I do it to one side, I have to do it to the other. Okay, so then this becomes 3 times, well, half of 8 is still 4. It's a negative, so it stays negative. Negative 4 squared gives me a 16 in my box, a 16 in my box. I see 16 times 3 is 48. 48 minus 24, I'm thinking in terms of hours, so that's 24. Okay, so 48 hours minus 24 hours, 2 days minus 1 day is 1 day, and that's 24 hours. That's where my brain went. And now I can divide both sides by 3. Now I can do the cheer, square root, plus minus. And I notice the square root of 8 is not a nice perfect little square, but it is, I can do, I called this birthday cake when I taught Algebra 1. I would divide by a prime, divide by a prime, divide by a prime until I got to a candle at the top. And so I have if you have a date, then you get to go out. If you don't, you have to stay home under the radical sign. So this pair comes out, this one stays home. So that is equal to 2 root 2. So I end up with x minus 4 is equal to plus or minus 2 root 2. And now I just need to add 4. So x would equal 4 plus or minus 2 root 2. And this is both of the answers. Okay, now that was a review. Now we're looking at conic sections. So there are 4 different conic sections, and we will start with circles. And so they're called conic sections because they're slices of 2 cones. So I had a cone here and a cone here, and when I slice parallel to the base, so it's parallel to the base, that gives me a circle. If I slice in such a way that it's not parallel to the base, but it's just passing through 1, this is an ellipse, which we will study next. If it's kind of slanted here and it doesn't, then this gives us a parabola, which is actually the 4th thing we will study. And the 3rd thing we will study is when you slice it in such a way that it's perpendicular to the base. This is a hyperbola, and let's see if I know how to spell. And there we go. Okay, so today we're looking at circles, and we will study the other 3 as we go. Each of these, by the way, can be defined, each conic section can be defined in how you slice a cone and also in terms of distance. So this part right here then lets us talk in terms of distance. Okay, so a circle is the set of all points that is equidistant from a fixed point called the center. The distance between the center and any point on the circle is called the radius. A circle is formed by slicing a cone parallel to the base. In standard form, well, here's standard form, HK. Oh, okay, in standard form, HK represents the center and R is the radius. Okay, so circles are actually the easiest of the bunch. So the center here is HK. If you think about it, it's been shifted H units right and K units up. The radius is R. And this comes from the distance formula squared. Okay, so if you think about, like, if I have a center somewhere here at HK, and I've got some other point, and I call this point x, y, and I want to find this, if this r is my distance, the distance formula, r would equal the square root of, we'd find that x minus h squared plus y minus k squared. We're finding the difference between those. And then maybe we could go more into this, but if I square both sides, I end up right back here. So this came from squaring the distance formula. So let's write a few of these. If the center is here, so then it's x minus 3 squared plus y minus 7 squared equals 8 squared is 64. And we're done. Okay, on this one I have x minus 8 squared plus y plus 5 squared equals, well, 5 squared is 25. The square root of 2 squared becomes 2, so 25 times 2 is 50. Okay, on this one, x minus 0, we just can write x squared plus y plus 4 squared equals 9 squared is 81. And there we go. Okay, so now we're writing in standard form the equation of a circle with the center and passes through the point. We have two ways to do this, and I'm going to show you both and let you pick which one you like better. One of them is to say, okay, this becomes the equation x minus 1 squared plus y minus 4 squared would equal r squared. Okay, so we just plugged in our center, and now what I can do is I can plug these points in to solve for r. So I can say negative 2 minus 1 squared plus negative 3 minus 4 squared equals r squared. I see a negative 3 squared is a 9. I see a negative 7 squared is a 49. And so my r squared is equal to 58. And I don't even really care what the radius is. I just can write, I need r squared for my formula. You know what, this may be the best way to do this problem, and just call that good. The other is to do the distance formula to find r. You know what? The distance formula would be, our radius would be equal to the square root of 1 minus a negative 2 squared plus 4 minus a negative 3 squared. And okay, maybe you find this easy. 3 squared plus is 9. 7 squared is 49. We just saw those two numbers. This becomes, r is going to be the square root of 40. That's not a 40. 58. And so x minus 1 plus y minus 4 equals r squared is going to be 58. So either way you want to do it, we were a little faster here because we already remembered the numbers from before. By we, I mean me. Okay. So now we're looking at, next one, we're looking at a circle that's centered at the origin, and it's got a radius of 5. So this would be the point 5, 0. And it's saying, okay, find the equation of the tangent line at 3, 4. So here's the point. I went over 3 and up 4-ish. Notice this gives me a 3, 4, 5 triangle, by the way. This is 3, this is 4, this radius is 5. We did that on purpose. And so I want the equation of the tangent line where it hits this point just once. And so what happens is this slope and this slope will be perpendicular. So this one we went up 4 and over 3. So this, the slope of the radius is going to be rise 4 is 4 over 3. So the slope of the tangent line is going to be perpendicular. So it's the negative reciprocal, so negative 3/4. Okay, so now my point slope formula, y minus y1 equals m times x minus x1. I'm going to plug in the point, oh, I needed it there. This is my point, y minus, pretend I didn't write an equal sign, minus the y value is 4 equals m is negative 3/4 times x minus 3. And technically we've written the equation. Now maybe I would tell you what form to write it in, but I don't feel like it. Let's just keep going. That is the equation of the line. We could add, we could distribute. We're just going to have to deal with fractions. If I don't want to deal with fractions, I can do slope is equal to change in y minus y1 over x minus x1. I can plug into here, and I had a slope of negative 3/4, and y minus the y value is 4, x minus the x value is 3. When I cross multiply, I get negative 3x plus 9 equals 4y minus 16. And now from here, I could put it in standard form, which would be ax plus by equals c, or I could go to y equals mx plus b. And so I add 16, I have negative 3x plus 25 equals 4y, and therefore my y equals mx plus b, negative 3/4 x plus 25 over 4. Sometimes that's easier for me than to distribute and then add. Anyway, I'm being lazy. I mean efficient. Okay, let's do a little bit more with circles. So sometimes they don't give it to us in standard form. So we have to manipulate this. We have to complete the square. So let's see if this is enough space for me. What I'm going to do is I'm going to complete the square with the x's, and I'm going to say plus a box. And then I'm going to complete the square with the y's, and I'm going to say plus a triangle. And I'm going to move anybody else. There was a 6, so that gets over there. But now I've added a box and added a triangle. So I have to add a box and add a triangle. There wasn't quite enough space for me, but whatever. Okay, so this part becomes x minus 3. Half of 6 is 3, and it was negative. 3 squared gives me a 9 in my box. And then plus y minus half of 2 is 1. 1 squared gives me a 1 in my triangle. I see 10 minus 6 is equal to 4. So now my center is at 3, 1, and my radius is the square root of that, which is 2. So I would come over here, the center, 1, 2, 3, and 1, and then I'm going to go up 2, over 2, down 2, this way 2, so that my radius is, pretend I can draw a circle, and there we go. Happily ever after. Let me do this one down below because I was writing too big. I have an x squared. You can't see what I'm doing, but okay. X squared plus the 6x plus a box. And then I have a y squared minus a 4y plus a triangle equals, and there was a negative 12 that I'm going to move over with addition. And then if I add a box, I have to add a box on the other side and have to add a triangle on the other side. And so now I have an x plus 3 squared. Half of 6 is 3. That gives me a 9. Plus half of 4 is 2. 2 squared puts a 4 in my triangle. And I see 16 plus 9 is 25. Oh, that's nice. That worked out nicely. And so my center is now negative 3, positive 2. And my radius is 5. Okay, so negative 3, 1, 2, 3, positive 2. Here's the center. Then we're going to go 5. 1, 2, 3, 4, 5. I think I can count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And, well, I've done worse. And there we go. And that's graphing our circles when it was given to us in this expanded form where we had to complete the square to get it into standard form. All right, like, subscribe, comment, and the only way to learn math is to practice. So go practice.